And good morning and Happy New Year to everybody. My name is Ramaya Krishnan. I'm Dean of the Heinz College of Information Systems and Public Policy at Carnegie Mellon University and the Faculty Director of the Block Center for Technology and Society. And it's my pleasure to welcome you to today's webinar on artificial intelligence and the future of work, hosted by the Stanford Digital Economy Lab and Carnegie Mellon's Block Center for Technology and Society. A word about both of the Digital Economy Lab is an interdisciplinary research group that studies how digital technologies are transforming work, organizations, and the economy. And the Block Center for Technology and Society is dedicated to examining how emerging technologies like AI influence the future of work and can be harnessed responsibly for social good. This discussion couldn't be more timely as AI is reshaping industries and changing how we're thinking about work. This webinar is designed to help give you an inside look at the report with two co-hosts who are the chairs who are going to be co-chairing this webinar, and they were the co-chairs of this National Academies Report. So here's a format for today's webinar. The co-chairs will give you a 30-minute presentation, after which there will be a Q&A, starting with pre-submitted questions. Please use the Q&A function in Zoom to submit your live questions. For those whose questions we don't get to today, please know that we received hundreds of questions, so did our best to combine similar questions to select the most popular. So let me briefly introduce the co-chairs who are Erik Brynjolfsson, so Jerry Yang, and Akiro Yamazaki, professor and senior fellow at the Stanford Institute for Human-Centered AI and director of the Stanford Digital Economy Lab, and Tom Mitchell, Founders University professor in the Machine Learning Department at Carnegie Mellon University, and also the chief technologist at the Block Center. Both of these colleagues are extremely well-known in their own disciplines, and they're connected to one another. Tom is also a visiting fellow at the Digital Economy Lab. So without further ado, let me hand this off to Erik and Tom. Take it away.
Thank you so much, Krishnan. It is such an honor to be able to share some of these results with everyone here. I'm glad to see so many people attending. I really was delighted to have a chance to work on this National Academies Report with a lot of esteemed colleagues, and especially with Tom Mitchell. He and I did the first report back in 2017, and I guess we liked it so much we signed up for another round, and we just finished this one. Obviously, the world has changed a lot. AI has changed a lot since 2017, so there are a lot of updates, and most of them in a promising direction. And looking forward to sharing some of our results with you all. Tom, why don't you kick it off?
Okay, thank you, Erik. And let me echo Erik's greetings, and thanks for spending the time with us. It has been an honor and a real education to serve on the committee developing this report. So let's get to it. This report was actually the result of the 2021 National Defense Authorization Act passed by Congress. And as part of that bill, it requested that the national academies do a new study updating the previous study that Erik just mentioned from 2017. So we put together a great committee of top people from industry, universities, various places, and produced a report, which I encourage you all to download and take a look at. What we'll do here is we'll take about 30 minutes to go through the key findings and results and recommendations from the report, and then leave plenty of time for discussion at the end. The first part of the report and the presentation is, of course, about AI technology. This has been a remarkable time the past couple of years in the field of artificial intelligence. I think it's fair to say the field has technically hit an inflection point with very rapid progress since the release of ChatGPT in November 2022. That has led to major new capabilities. It's kind of hard to remember, but before November 2022, you really could not have a decent conversation with a computer in natural language, and that has changed. We also see slower but steady progress in many other areas of AI too, including, for example, speech recognition, robotics, and other areas. But the big progress has really come in the past few years from large language models like ChatGPT, Gemini, and others. And just to kind of calibrate us all, remind us all what has happened in the 25 months since the release of that ChatGPT. Already we've seen improvements, although not elimination, of the problem of hallucinations, and improved safety, although not elimination, of some of the downside risks of these systems. But we've also seen technical advances such as these large language models being able to call out to software tools like search engines, calculators, to fill in some of the knowledge that they themselves don't quite have. We've seen them extended from the original language only to being able to handle images, and then from images to videos. We've seen the development of a very robust open source movement where the open source software community is developing many variants of large language models that are in fact small enough to be portable, and some of those are in fact small enough that they will fit on your phone. And we're beginning to see now language models that will be on our personal phones this year. We're beginning to see software agents, speaking of LLMs on your phone, software agents that can, on your behalf, operate some of the other apps that are on your phone or your desktop. We're seeing, beyond large language models, large multimodal models that handle video, sound, and other modalities, beginning to catalyze progress in robotics. We're seeing amazing new ways of embedding these into new kinds of user interfaces. If you haven't looked at Notebook LM from Google, I encourage you to do that. You can give it a PDF file and it produces a podcast discussion between a man and a woman synthetically discussing that PDF file. In the most recent version of it, still experimental, you can actually interrupt those speakers during the podcast and jump into the conversation yourself. We're beginning to see also new types of inference time computation, language models that take many seconds or minutes to think about an answer before providing it. So much has happened in the last 25 months. There are forces that are accelerating progress in AI, primarily large investments both by governments and industry, but other forces that are retarding progress, slowing it down. For example, the need for social acceptance and development of trust in these systems, government regulations, and in fact, in some cases, decisions by companies to limit excess. So the findings in this section of the report are that AI is in fact a very general purpose technology. Erik will have more to say about that. But it has undergone rapid progress. And though it remains imperfect in many ways, it's important progress that's going to impact us. We expect significant further advances in the technology in the coming months and years, but we also find it's highly unpredictable. It's very difficult to predict exactly which advance will happen, exactly when, and therefore a key theme of the entire report and our thinking about the problem is that we need a robust solution that will work across a variety of possible futures. The rate and the extent of the effects on the workforce are going to be modulated by several non-technical factors in addition to technical progress, how organizations and society responds. And it's going to take, for governments, much deeper technical knowledge than they traditionally have had about AI in order to govern, regulate, and guide this technology forward. So in the report, we mentioned several opportunities to influence this technological future, ranging from supporting basic AI research to developing standards and guardrails that, in fact, may promote and accelerate adoption of AI by providing a more well-understood playing field, providing incentives and standards and regulations to encourage sharing and transparency regarding training data, and to support, importantly, to support specific kinds of applications of AI, for example, in education, where market forces might not be enough to encourage private investment to develop those applications. Finally, we recommend funding initiatives such as the National AI Research Resource, which is an attempt to provide hardware, computing hardware, to keep U.S. universities vital players in the AI research frontier. So with that, let me flip it over to Erik to talk about AI and productivity. Erik.
Thanks, Tom. So productivity, next slide. Productivity is not everything, but it's been said that in the long run, it's almost everything. Productivity is really the key thing that determines our long-term living standards and the wealth of nations. And so that's why we made it our first chapter about the effects of AI going forward. Where does productivity come from? It comes from general purpose technologies, and those are defined as technologies that are pervasive, improving over time, and that most importantly spawn complementary innovations. As Tom just mentioned, AI we consider a general purpose technology. It is the big, important general purpose technology of our era. The exact effects are going to depend on the adoption and use in different sectors and tasks. So far, we have not seen a big productivity surge from AI or generative AI. Productivity has actually been fairly minimal most of the past decade. The past couple of quarters have been looked more promising, but it's too early to tell for sure. That said, given AI's wide applicability and also the rapid technical development that Tom mentioned, we do expect significant impacts to be likely in the coming decade. So next slide. Let me talk a little bit about those impacts. So one way to look at that is you look at specific applications. So there have been a number of studies in contact centers, one that I did with some colleagues in software development, several studies there in writing and others that I'll show. And there are other tasks that just aren't suitable. And so you can divide the economy into those different categories. Trying to understand how it would turn into productivity. What you can do, I'll show you in the next slide, some estimates that say that it may more than double from our current rate of productivity growth of about 1.4% per year to perhaps 2.8 or 3% or more per year going forward. In addition, there's been recent research showing that AI has the potential and has in some cases significantly accelerated scientific discovery and innovation. So that would compound the productivity gains. It would not just raise the level, but put us on a faster trajectory of growing even more rapidly. There's a lot of uncertainty about this. It's not easy to predict what the way productivity is going to play out. In particular, even when you have impressive technologies, there are bottlenecks that prevent those gains from turning into real benefits. Often it can take years or decades for those to be worked out. So that means that we need some institutional and policy changes to make sure those productivity gains get widely shared and they don't lead to negative effects like job losses and wage disparities in different areas. So let me talk a little bit about those potential effects in the next slide. So it's, as I said, it's too early to tell for sure, but we did some, calculations, some estimates. So if you click forward, one approach is what's called Hulton's theorem, which is sort of a first order approximation to any arbitrary production function. It's really a pretty simple calculation. In the report, we go into more detail, but it basically boils down to multiplying these two terms. The first one is which tasks are exposed. So there have been various estimates. There's a paper called GPTs in Science that we reference that estimated about 40 to 50% of the tasks in the economy currently particular. And then you have to estimate how much of an improvement could you get. And some of the studies that I pointed to earlier had double-digit gains. 20% is actually at the low end. Some of them were significantly more than that. If you simply multiply those two numbers together, you get about an 8 to 10% productivity improvement from these technologies. You then have to divide that over 10 years because these effects don't happen instantaneously. That's what we sometimes call the productivity J curve, that there's a lull or even a negative period while organizations are being restructured, and then things take off. So that drops you down to maybe 1% per year of productivity gains. That may not sound like a lot, but that's actually a pretty big jump compared to what we have currently. And then on top of that, there's the future AI progress that Tom mentioned. So that boils down to perhaps doubling productivity growth from our current 1.4% to 2.8% or more, as I mentioned earlier. Next slide. So the findings we have are, basically two big ones, that there's these substantial and these ongoing improvements in AI capabilities off these significant improvements in productivity. That kind of potential doubling in productivity could do wonders for our ability to provide healthcare, address environmental problems, reduce poverty. The budget deficit would be significantly improved. Just as a benchmark, back in the 1990s, we had productivity growth at that level, and the budget deficit was actually wiped out. But in order to achieve these, we need to make a set of complementary investments in new skills, new organizational processes, and new structures. Technology alone is not enough to reap these kinds of productivity gains. Okay, next slide. So what can we do? Well, we can provide, fund, and disseminate data and statistics on what's working, what's not working. There's a lot of hype. There's a lot of billions of dollars being wasted on technology implementations that don't work, but there are many that are working. And as we review some of those in the report, as I mentioned, the call centers, coding, writing, etc. And a related policy we can do is to encourage labor mobility as new occupations and firms and opportunities emerge. We want to have people be able to flow to those. The U.S. economy is not as dynamic as it was 20 or 30 years ago, and that's holding back the ability to take advantage of these technologies. And then we're going to have to update our product liability, copyright, privacy, and bias to make sure that these are not only creating the benefits, but also not creating unnecessary harms. Next slide. So the second chapter about the impacts was on AI in the workforce. And to give you a little structural context, we are not having mass joblessness right now. In fact, unemployment is near record lows. We almost have record highs, or at least decade-long highs, in the share of the workforce that's employed. And furthermore, if you look forward, population labor force growth rates are likely to be slowing significantly. So there are going to be fewer and fewer workers entering the workforce. So we actually need something to compensate for this reduced labor supply going forward. Next slide. So we looked at three different scenarios. As Tom said, it's difficult to make sharp predictions, but we can play out a few different scenarios. Two of them are not so good. One of them is more encouraging. The first scenario is kind of business as usual. Over the past couple of decades, technology has led to increased polarization. That is to say, reduction in middle-skilled jobs and increases at the top and the very bottom, as opposed to middle skill. While that's what happened in the past, we don't necessarily think that the new technologies are the same. So a straight extrapolation is probably not the most likely scenario. Another scenario that we hear a lot about, especially out here in Silicon Valley, is that AI just becomes so broad, it's not just the middle skill, but also the high and the low that get outcompeted by AI. We don't think that's likely in the near future, at least. It's harder to say further out. But in addition to the limitations of AI, there's all these demographic trends that will actually require some labor supplementation. And finally, a more encouraging one is that we get more demand for expertise, both for elite and mass expertise. And AI can actually be used to empower and reinstate mass expertise in many different domains. So let me talk briefly about that. Next slide. Historically, technology has both destroyed the need for expertise and also created need for new expertise. For instance, in the past, artisanal skills were eroded by factory the system, or repetitive and clerical and production tasks were eroded by computerization. Next slide. At the same time, we've actually seen a tremendous increase in demand for other kinds of jobs and other kinds of expertise. And this chart from our report shows that while there are some categories like farming and mining that had reduction in employment and demand for those kinds of skills, there were many more actually categories which had an increase in new work and an increase in existing work as well. And you can see that by the green and the red bars to the right. You can see most of them are growing in many different sectors like professionals, clerical administration managers, et cetera. It's plausible that AI will have similar effects, eroding categories, and those are the easier ones to see, but also creating new things we haven't seen before, and those are harder to predict because we just don't know exactly what they are yet. Next slide. So the questions is to think harder about, okay, which ones are going to be substituted or made obsolete? And we can see a set of tasks where AI works, and I alluded to those earlier, and it may become broader as we get continuing progress in robotics. So it starts addressing a lot of physical tasks that currently aren't on that list. But then we also have to try to do what we can to think about what are the new tasks and ways that AI can complement expertise. We're seeing that in some categories, helping people make new kinds of diagnoses or evaluating a broader range of building designs for architects. Next slide. So the findings are that AI can both be used to improve worker outcomes or to displace them. And the consequences will depend not only on the capabilities, but also on a whole set of demographic, social, institutional, and political forces that are not technologically determined. We should not focus only on the displacement. We should also think about the reinstatement and the complementarity. And finally, even where AI does lead to higher worker productivity, there's no guarantee that everyone's going to benefit. In the past, it's been very uneven. And going forward, we have to be mindful that we're not necessarily going to get broad-based productivity growth if we don't make the right sets of changes. So next slide. So there are things we can do to try to make it more likely that AI not only is productive, but it creates widespread prosperity. We call for looking for ways to have AI complement humans and improve quality, not just replace them. Foster inclusive AI adoption, focus on augmentation, not just automation, have a set of legal norms that protect worker rights. Within the federal government, we need to revamp and increase AI expertise substantially. Right now, there's not nearly the expertise that's needed to have the effective investment, oversight, or regulation. And then we can look at these technologies and understand better which ones are complementary in publicly funded programs in education and healthcare. Next slide. So with that, let me turn it over on that point in particular to Tom, who's going to talk about AI in education.
Thanks, Erik. So we have an entire chapter on education in the report, and I encourage you to take a look at that. But the key points are that AI is going to have a significant impact on the demand for education, in particular for continuing education by the workforce because of the churn in jobs, the changes in jobs that are likely to come about from AI. And that will increase the demand for retraining, learning the new technology, and so forth. But at the same time, AI is very likely, we're already starting to see, it changed the way that we provide or supply education. And for example, we're seeing now chatbot type interfaces as tutors for school children and new kinds of continuing education training that rely on those. And so that's a significant opportunity to improve the ability to customize education to the needs of individuals using AI. It's also likely to shift at the level of elementary and primary school what we should even teach to the next generation. We could talk more about that maybe in the discussion period. So the opportunities we see here are to support research on continuing education in particular that will help foster workforce flexibility, and how AI and augmented reality and other technologies can be used to improve the way that we actually do education. Interestingly, we found also that as new training programs are introduced, there's a need for standards and certification for those training programs in order to make it clear to the companies that want to hire these people, what does the certificate from this community college with this program really mean in terms of the work skills that this potential employee will have? So getting those standards in place and that kind of certification process will be key to making the connection between education and employment. And finally, we should spend some time looking back at kindergarten through 12th grade education and ask, how should we be teaching our next generation, given the fact that they're going to grow up in this different kind of world where AI technology is available to them. So with that, let me move over to Erik to talk about measurement.
Thanks, Tom. And next slide. So one of the big benefits of getting to work with Tom twice, aside from the fun we had, is we got to really see how things have changed. In the last report, we had a lot of takeaways, but maybe the most important one we wrote a Nature article about, was that we just didn't have the data to make good decisions and understand what was happening in the economy. We wrote an article in Nature with the subtitle "Flying Blind." Well, that's changed a lot, thanks to a lot of hard work by folks in government and in the private sector. So compared to the earlier report, we have a lot of new data. The census is now collecting data from businesses about the adoption of AI. Earlier this morning, I was just talking to a bunch of colleagues about the census data from the ABS and other sources, collecting data on robotics and adoption of AI. We're adding new questions to additional surveys. So it's been a sea change, and I'm grateful for the hard work by the people in the statistical agencies to collect a lot more data. And there's a whole set of researchers now working on these issues. We could do even better if we had legislation allowing statistical agents to share some of the business data more widely and get more people involved and continue to work on a shared schema so that agencies would have consistent definitions. Even just defining what AI is can be tricky. Next slide. The other side we've seen big advances is in private sector data. We're fortunate to have some people like Neela Richardson from ADP on the committee, and they were very generous in sharing some of the data, and they continue to be generous sharing it forward. Neela's made a lot of that data. We're sharing it through the Digital Economy Lab with a lot of folks hosting it here, from about wages and employment and skills and how that's changing. So there are other kinds of data. You're all familiar with the kinds of things you can see on LinkedIn that could be aggregated up to industry and occupation and region and a company. There are information on job postings, hundreds of millions of job postings through Lightcast and other sources, and Indeed. So these are amazing. And now we have the opportunity to combine these two data sets that have both improved all kinds of data, the public and the private. Next slide. So that is, of course, what we recommend going forward is continuing to improve the government data collection, and kudos to what's already been done. But the more high frequency real-time data we have, the better we'll be able to understand these changes. They're hard to predict, but if we measure them, we'll be able to sense and respond more quickly, and also create public-private data partnerships. There's a real willingness. It was gratifying among private sector providers to share versions of it in a way that doesn't violate privacy and it doesn't undermine some of their strategic benefits. But they are open to that. And if we have a vehicle to make that easier, I think we'll be able to have a lot more private data that's accessible and combine it with the public data. And I just want to stress, by the way, these are not substitutes for each other. They are complements, a word I've been using a lot. The private data is amazing in terms of often being very fine-grained in real time, but it's not representative in most cases. It's not designed to be representative. So it often overcounts certain categories, undercounts other categories. The public data can be much more representative. And if you use that to calibrate the private data, then you can really get the best of both worlds. Next slide. We can also measure the heterogeneity in the AI adoption. When you get this more fine-grained data, it's not just one pattern across the whole country. There's a lot of differences, and obviously in occupations and in industries, also across geographies, and you need the fine-grained data to do that. And finally, we can use this data to instantiate some of the scenario planning that I touched on earlier, start seeing whether we're beginning to see the early evidence of any of those three scenarios that I showed you earlier. Next slide. So with that, let me turn it to Tom, and we'll bring this home.
Thanks, Erik. So one of the themes I'm sure you've picked up listening for the last 20 minutes is a great deal of uncertainty about exactly what is going to happen with the technology and how the impediments to adoption are going to be resolved. And so one of the messages of the report is that given that great uncertainty, we should also spend some time considering the possibility of much more rapid AI progress than most people expect. It may or may not happen, but it's worth spending some time thinking what would happen if AI, for example, advanced fast enough that the effects on the workforce would be much more rapid and much greater. And so given that, we think that what we can do about that is do some research to look at what kind of policies and strategies would we use to address the social and economic implications of more rapid than expected AI progress, do some scenario planning, put together a dashboard of key indicators so that we can track. This ties back to Erik's comments about measurements, but a dashboard that helps us track more accurately what really is going on in the economy so that we can detect the speed of progress. And finally, put together some policy options around there. So with that, let me leave up this key takeaways slide. The wrap and brief, those takeaways are AI, we expect to have big effects on the economy and society, but they're not predetermined. It's not just technology determines what will happen. Our own choices really do matter in this. For workers, one way that we find most helpful to think about it is how is AI going to reshape the demand for expertise? And Erik's discussion of that really focuses on questions around expertise. What types will be in more demand? Which ones will be in less? We need to empower workers and decision makers by collecting and disseminating more information, more real-time information around supply and demand of skills and how that's changing in the workforce. And we need to spend time in especially continuing education, because that will be a key to enabling the workforce to adapt. And so final message here at the bottom is really an important one. The message is simply that we all really have a voice in this. It's not technologically determined, but policymakers, business leaders, researchers, all of us, in fact, have an opportunity to shape how this is going to play out. The more informed we are about it, the better we'll be able to do that. So with that, let me call this presentation to a conclusion and turn it over for questions.
Great. Thanks. So I see some questions have already been collected. We have actually over several hundred of them. So need to say we're not going to be able to get to all of them, but let me try to get to a few. There's a question from Dennis Ost. Given society's experience with globalization, can we realistically expect to enjoy the benefits of AI without screwing it up? That's the big question. As Tom said, there's no inevitable determinism. But I think globalization is a good cautionary tale because a lot of economists looked at globalization and said, hey, this is great. You can make the pie bigger by having free trade. Both countries or all countries benefit from it. Of course, there's going to be some winners and losers within the countries, but if the pie is bigger, we can compensate those people and make sure people are better off. It didn't turn out that way. There was a lot of free trade agreements and the pie did get bigger, but it was extremely uneven. We didn't do the second half of that bargain where we made sure that people were cushioned and benefited. And now there is a big backlash against both globalization. The new administration is looking at putting tariffs in place and things are unraveling. I think that's going to make the world poorer. But I can understand that people were upset that the previous bargain didn't work out so well. We have to make sure that doesn't happen going forward. Technology is very similar. It's going to make the pie bigger, but it's going to be uneven. And if we don't take steps to make sure that we create not just higher productivity, but widely shared prosperity, there will be a backlash, and that will really hurt society quite significantly. Tom, you want to pick one?
Great. Yeah, let me take one. Here's one by Ivan Rahman. Which asks, how can policymakers and educators proactively address the challenges of AI-induced job displacement? That's a great question. It's really at the core of what we need to confront. I think in some ways, it's kind of common sense. What do workers need? Workers need, number one, better timely information about what is actually happening in terms of the demand and supply for different kinds of skills. And is the job that they're doing and the skills that they have one of those that's in increasing demand or decreasing? Are there different parts of the country or different regions where those skills are in more or less demand? They need better information about that. They need a voice, number two, in how AI is used to change their jobs. One of my favorite examples of this is in my home state of Pennsylvania. The governor was interested in how AI could improve government practices in the state. And instead of doing a top-down committee to decide that, what he did was he got a couple hundred licenses for ChatGPT from OpenAI and put those licenses to work behind the firewall of state government data sets, and then had a competition among government employees to propose why they should have one of those licenses themselves to use as part of their job. So it's a very bottom-up, give the people who are doing the job the chance to innovate and suggest how AI can be used to improve their job. So number two, workers need that kind of voice, at least a key voice in defining what can be done. Number three, they need better opportunities for continuing education. And already community colleges are beginning to respond to these changes, but there's a lot more we can do there. And you could even imagine policies that involve tuition tax credits or various ways of incenting or making it more affordable for people to invest in that kind of education. And finally, as Erik mentioned, workers also need a fair share in the prosperity and increased productivity and the wealth that's being generated by this. And the current system we have is really not, unfortunately, not tuned to spread that wealth equally. Erik, do you want to take another?
Sure. Let me cheat and take two real quick. So first one from David Tickol. He says, will the video of this will be available online? And if so, how? My understanding is yes. And I'm going to ask the team to put in the chat or online the link and the explanation of how people can see the video of this going forward. And let me also take the one that is right under it here from Emma Brunskill, a colleague, who says, what are your most optimistic takes about how AI may reduce inequity in terms of wealth? So let me say two things. First, on the technology, and then on some of the choices we make in policy. This technology appears to be playing out somewhat differently than earlier technology, the most recent types of computers, which tended to be skill biased and increase in inequality in wages and in capital labor. Some of the uses of this technology have actually disproportionately benefited less skilled workers. For instance, in a call center study I briefly mentioned, we found that the average productivity gain was about 14% for the workers using this tool versus those who didn't. But the least skilled workers, the bottom 20%, had about a 35% productivity improvement and actually became much more productive and ultimately got more wages. Whereas the top quintile actually had roughly 0% improvement. So there wasn't much of a benefit for them. We think what was going on was that the technology was looking at these millions of transcripts of conversations, some of which were successful and some of which were not successful, and learning from the successful ones, using that as training data, and sharing the tacit knowledge. As Tom and I wrote in a science article earlier, machine learning is very good at capturing some of the tacit knowledge that we previously couldn't have captured. Makes it available to less skilled workers, improves their performance. But the most skilled workers were already doing what the system was suggesting, so they didn't get as big a lift. For better or worse, that not only increased productivity on average, but it disproportionately helped the less skilled workers. That pattern is something that showed up in a lot of other studies since then in writing and coding and elsewhere. So it's common, but it's not universal. There was a recent study by Aidan Toner Rogers, a grad student at MIT, who found that actually when you went in a study of helping with scientific discovery, the good news was there was about 39%, I think it was, or some in the neighborhood of 40%, more materials discovered by material scientists who were working with the technology versus those who have been randomly assigned to not have access to the technology. But in his case, he found that the more skilled workers were benefiting more. So there is evidence in both directions, something to look at more closely. Briefly, I'll also say that there are a lot of things we can do on the policy side. There are things we can do to reduce wealth inequality, to create a more flexible safety net. In Denmark, there's something they call flexicurity, which provides a safety net while also allowing for the kind of dynamic labor market that I referred to earlier. And if the pie does get bigger, there'll be more room to be generous about that and not only help those who were left behind, but actually even those who are doing well will also be able to continue to thrive. So there's certainly room to succeed on that if we make those choices. Back to you, Tom.
Okay. Here's the question. What is the anticipated effect of patient diagnosis by AI on physicians' motivation to maintain updated medical knowledge? I like this question because it kind of brushes really up against the fundamental question of augmentation versus replacement and how is this all going to play out. So it seems to me that first of all, doctors are not going to go away. And the reason is that it's the customers of doctors, you and I, the patients, who decide whether we're going to want to go to a human doctor or a computer. In fact, what we're seeing today, for example, in the area of radiology, the evaluation of medical imaging, is that computer tools, AI tools, are already very good and very helpful in giving second opinions to radiologists. And many radiologists now use those tools to improve the quality of the radiology diagnoses that they're making. Now, you might think that that increase in productivity would decrease the amount of radiologists we need. But in fact, what has happened is that there's been an increase in the number of radiology requests because of the increased productivity and reliability, there's more demand for radiology tests than there had been. So this also illustrates a kind of an interesting phenomena, which is that increasing productivity, which would in fact result in needing fewer radiologists if all other things remained equal, but increasing productivity might make all other things not remain equal. There might be more demand if in fact it's more valuable and lower costs at the same time. So let me end there and pass it back to Erik.
Well, let me just say I'm very proud that some economics has drifted over to Tom. I've tried to learn some computer science from him, but Tom's exactly right, and this is something that I think is not as widely understood, that there's a downward sloping demand curve. If without giving you PTSD, bring you back to your economics classes, as the price goes down, there's generally an increase in quantity demanded. And sometimes that increase is quite large. So it doesn't necessarily mean that making something more productive or more efficient means that you spend less on it. Sometimes you end up spending more on it and you just get more output than you would have otherwise. And that, that could be a win for everybody. Let me take a question here from Jake Carr, Butte County Office of Education. He asks, will AI drive rolling job market changes? And if so, how long might this disruption lasts before a stable, adapted workforce emerges? I don't think I have good news for you there. I don't know if it will ever have a stable, adapted workforce. I think it's going to be continuing dynamism. But in fairness, we've always had dynamism and disruption in the economy. As I showed, the work that David Otter has done, and it was used heavily in our chapter on the workforce. About 60% of jobs that we have today didn't exist in the 1940s. So there's been technology has always been destroying jobs, has always been creating jobs. We expect that to continue going forward. And the answer is not to try to stop it or say, hey, let's just see if we can freeze things. That's never been a successful strategy for the United States or any country, really. You have to lean in and adapt to the changes. Have a dynamic economy that allows you to take advantage of the new things that are being created, that increased demand that Tom touched on, the new kinds of jobs. And that means constantly learning new skills. If anything, it's going to have to happen even faster going forward. So our prescription is not to try to find stability, but rather to roll with the dynamism and make sure that people can adapt quickly and where necessary, have mobility between jobs, between occupations, between regions, learn new skills, and have the new embrace the new technologies where they're appropriate in a way that create broad-based benefits. Back to you, Tom.
Okay, I'm going to take one that showed up in the chat from Ian Helfrich, who says, I've had the distinct fortune of using AI to teach quantitative methods at Georgia Tech, but also for online community college students. And the improvements for lower skilled students, he says, is profound when implemented correctly. AI helps improve the efficacy and agency of students at the lower abilities end of the spectrum when used correctly. So I think that's not quite a question, but let me riff on that, because I think it's an interesting data point that I've seen before. For example, in a Chinese education company called Squirrel AI, they noticed similar phenomena that students at the very low end often really benefited tremendously from AI tutoring systems. But what's interesting and going on right now in AI in terms of delivering education is there's a tremendous amount of experimentation going on. We don't yet know which of these experiments is going to produce better learning outcomes for students. That needs to be measured carefully so that we understand what we're doing before we release this scale on students. But for example, groups like Khan Academy are experimenting with using AI tools to help students, kindergarten through 12th grade students, learn to write essays. And if you're stuck with writer's block, one strategy is the AI tool says, well, I'll write the next sentence. You write the first sentence. I'll write the second one, then it'll be your turn again. So kinds of interactions that we never really could have with computers that we can now have open up all kinds of possible educational strategies. Earlier, I mentioned in the presentation, Google's LM Notebook, which allows you to automatically synthesize a podcast discussion between people, and then you can jump into the podcast and become one of the conversants yourself. Imagine using that as a way of helping a student go through the chapter in the textbook that they don't quite understand. Another idea from one of my own PhD students, Robin Schmucker, was why don't we have students learn by teaching a student bot? And so he built a student bot out of GPT-4, had students teach it, and he had a second bot, a professor bot, overlooking the human teaching the student bot and giving advice when the human got stuck teaching the student bot. So these are some of the kinds of really out of the box and completely unheard of ideas as recently as 3 years ago that we can now experiment with. And so I think we're in for a very exciting next couple of years as we start to measure and understand which of these ideas actually pay off in terms of educational outcomes. Erik?
Yeah, I really like that, Tom. It touches on one of the more philosophical questions that Martin Hepp asked. How do we keep up with our human ability to challenge and validate, or in the sense of Karl Popper, to falsify the outputs of AI if it becomes increasingly hard and discouraging to develop and maintain the same set of skills like math, reasoning, etc. So we are going to have to rethink how we learn and the kinds of skills that we have. I'm finding it a challenge in my own teaching where, the kinds of assignments that I gave a couple of years ago, I can't give the same ones because ChatGPT can actually do a lot of them pretty quickly, and it bypasses the student learning that would be needed. But the examples you gave, Tom, of how you can use these tools for new kinds of teaching and learning are important. Also, more philosophically, there's an article in the Wall Street Journal 2 years ago, I think it was, by Eric Schmidt, Henry Kissinger, and Dan Huttenlecker from MIT, talking about how the nature of knowledge and understanding were really changing. They described 3 eras. There's the pre-scientific era where there's a lot of superstition. We thought that rain came from the gods being angry or whatever. Then there was a scientific era where we really could figure out and understand things. And they speculated that we're entering an era where AI is going to be able to answer a lot of questions for us, but not be able to explain them to us as well as we would like. And we need to work on having AI that not only gives us correct answers, but interprets those conclusions in ways that humans can comprehend them. And that's going to be a challenge for us going forward. Back to you, Tom.
Let me just riff on that a little bit and get to the question of how should we be teaching the next generation of kindergarten through 12th grade students? And this kind of bumps up against several of the questions I see in the chat. Here's my personal take. I'll be brief. I think what we need to do is to teach the next generation essentially to be CEOs. And what I mean by that is that a CEO has to make important decisions, like should we sell this new product or not? Should we open a new office over there? And to make those important decisions, they have big financial consequences. The CEO has a team of experts. The CEO has a CFO who knows more about the finances than the CEO does, has a chief of marketing who knows more about how to market the product than the CEO does, has a chief of engineering who knows more about how to build it, what can be built. But the CEO has the skill of tapping into these experts, even though they're all subjective and fallible, they can make mistakes. But the responsibility of the CEO is to learn how to manage a team of experts to make important decisions. And it seems to me that's the environment that our next generation is going to find themselves in, because they will have an AI system that can act as a collection of experts in different topics to support them in the decisions that they have to make. So it's that kind of skill of dealing with a team of experts that are fallible, understanding what questions to ask those experts, how to judge the answers that come back, and how to assimilate those into a final decision.
I love that metaphor, Tom. I think it's exactly right. We all have to learn how to ask better questions, even as the AIs are better at providing better and better answers. Pointing them in the right direction and having that leadership to ask the right questions is going to be the key skill. I see that we're just about out of time here, so I'm just going to use Seth Neiman's question to make my closing comment. He asked, might we drive tax policy to emphasize greater augmentation rather than automation? I think that's very possible. Right now, we have taxes that are skewed towards favoring automation and capital investment. They have lower taxes on capital than on labor. And so entrepreneurs when given the choice, are going to be steered in that direction. They don't need to be steered in that direction. We could steer them more neutrally or even towards augmentation by flipping that tax policy. But more broadly, what I want to say is that, the theme that Tom pointed out in his part is that there's no inevitable future here from the technology. It's not what AI is going to do to us. It's how we want to steer it and what we want AI to do for us. And we have a lot of agency, both as policymakers and as managers, and for that matter, as citizens and workers. And one of the themes of our report is to understand these different scenarios and these different possibilities and proactively work towards the ones we want, which we think most people would prefer a world of shared prosperity. We don't think that's an inevitable future, but it's one that's very possible if we make the right choices in those directions. And that's what we outline in our report.
Well said. I think we are at the end of our hour. So I think on behalf of Erik and myself, thank you all for a really interesting discussion. It's clear that if we had another 2 hours, we'd still not get to the end of the comments and questions that are here. But there's plenty of time going forward to have more discussions. Thank you all.
Thank you.